Our next focus is the annual missions. We want to get to a cadence of doing our missions annually so we can maximize that science, maximize the utilization of our systems on the surface of the moon. And we start with the 2 crew, initially moving on to 4 crew, which is the ultimate test of our systems that we're trying to validate before we can go on to Mars, which is our next focus. So we're trying to use the moon and space station and future commercial LEO as analogs for our Mars missions, both of our systems and of the human system as well. We're also looking to do our robotic sample return to understand the volatile composition as well. And our 4th focus area is our partnerships. Our international partners are invaluable to us executing today on space station and also what we've laid out in the current Artemis program and our future missions as well. And that is existing partners and new partners that we'll have moving forward. We also have our industry partnerships, which span many applications, from delivering direct hardware to us to sharing of data, and future ways that we'll partner with industry as the space industry expands. And as we move from our focus areas to our Mars missions, what I'd like to share with you is a conceptual Mars missions. So when we take a step back, Spuds showed you the scope chart of what the objectives entail. We take a look at what we need to do a 30-day surface mission on Mars. What are the minimal capabilities we need? First, at the top, you see we need that transhab, and we need our propulsion to get us there. In this particular reference architecture, we use the hybrid propulsion stage to get us there, meaning chemical and electric. But before we take our crew, we know we need to get provisions there for them. And that's first doing a pre-deployed cargo lander with an analysis that shows we need the 25-ton class payload. We need some of the propellants at send ahead and surface power. We then would need to send ahead the crew ascent vehicle. We need to make sure we know we're going to get them off the surface. And then finally, the crew, which in this reference architecture, we've landed in a pressurized rover. Our assumption here is the crew will be deconditioned and will need as much time to adapt to the partial gravity. But we want to maximize the science, so we allow them to drive around before they become conditioned enough to get in the spacesuits and walk and maximize that science in 30 days.